Physics, at its core, is a set of rules. It is a contract that the universe signs with us. It tells us that gravity pulls down, that water flows downhill, and that a soft object cannot penetrate a hard object without being destroyed. If you take a piece of straw, a brittle yellow piece of dry grass, and you throw it at a telephone pole, the straw breaks, the wood remains. That is the contract. That is the rule. There is a photograph, preserved in the archives of local history, that shows something that shouldn't exist. It is a hardwood tree, an ancient, sturdy oak, and jutting out of the side of this tree, pierced directly through the thick, rugged bark and driven deep into the heartwood, is a broomstick. Now, stop and think about the kinetic energy required for that to happen. For a piece of soft pine, the handle of a broom, to act as a spear against a hardwood tree, the acceleration has to be so sudden, so violent, that the wood fibers of the broom don't have time to shatter. They don't have time to realize they are hitting something harder than themselves. They simply pass through. This is what was waiting for them. While the farmers in Richland County were looking at their crops and the teachers were dusting their chalkboards, the atmosphere above them was constructing a weapon capable of driving chickens and their coops from one county all the way into the next, leaving them miles away from home. This is the story of the Horrell Hill School. It is the story of 75 children, 4 teachers, and a sky that turned a color no sky should ever be. It is the story of the longest, most violent tornado track in the history of South Carolina, and it is a story about the terrifying fragility of what we call normal. Imagine the soundscape of the rural South a century ago. There is no hum of the interstate in the background, no air traffic overhead, no televisions chattering in the living rooms. The world was quiet. It was intimate. If a dog barked 3 miles away, you heard it. If a train was coming, you felt it in your boots before you heard the whistle. It was a Wednesday, April 30th, and by all accounts, it was a miserable, sticky morning, the kind of humidity that clings to you like a second skin. The air felt heavy, thick, but the people of Horrell Hill, a small, tight-knit farming community just southeast of Columbia, they didn't have Doppler radar. They didn't have a National Weather Service warning system beaming to a smartphone in their pocket. They didn't even have sirens. They had the arthritis in their knees acting up. They had the way the birds stopped singing. They had the barometric pressure dropping so low that it made their ears pop. Think about that distance. That is not a touchdown and lift-up tornado. That is a grinder. That is a machine that lands and stays. It traveled from the Georgia border, almost to the ocean. They just knew the sky looked wrong. Now, why green? We've all heard the myth. Green sky means tornado. But scientifically, that green glow is terrifying. It happens when sunlight is scattered through a massive, dense core of hail. It means the cloud above you is so tall, so full of ice, that it is filtering the light spectrum. These weren't pebbles. These were stones the size of eggs, 1.75 inches in diameter. Can you imagine the sound? This was the first warning. But because of the normalcy bias, that psychological trick our brains play on us to keep us calm, people didn't panic. They didn't run to the cellar. They looked out the window and said, "Wow, look at that hail." They marveled at it. The hail stops. And then, the most dangerous thing of all happens. The rain stops too. The wind dies down. And a heavy, suffocating silence falls over Richland County. In that stillness, at the Horrell Hill School, life was proceeding exactly as it was supposed to. The Horrell Hill School was the pride of the community. It wasn't a shack. It was a sturdy 2-story wooden structure. It had heavy timber framing. It was built to last. It was a symbol of progress, of the future. Let's focus on one room. James Howell Morrell. He was the teacher, a man of logic, a man of numbers. Morrell was in the middle of a math problem. He was explaining the certainty of numbers to a room full of children who were probably distracted by the heat. He is holding the chalk. He is writing a number. And then he hears it. It wasn't a sudden crash. It was a rumble, low frequency, almost below the range of hearing. a vibration that you feel in your chest cavity more than you hear with your ears. To the west, the children, noticing the teacher has stopped, they look up, they look at him, then they look to the windows. This didn't fade. It got louder and deeper, a continuous, grinding roar. L.B. Harmon, who was just a first grader at the time, a little boy named Bertz. He remembers the sound. He remembers the confusion. In the classroom, the air pressure begins to fluctuate wildly. Your ears pop. The hair on your arm stands up, not from fear, but from the static electricity building up in the air. The atmosphere is becoming charged. He is a rational man. He expects to see a storm. He expects to see rain. But what he sees breaks his understanding of the world. He is looking for a funnel. We all know the shape. The cone. The finger of God descending from the clouds. That is what a tornado looks like in the drawings. He sees a wall, a massive, churning, solid wall of white, and it wasn't moving across the horizon. It was getting bigger. The speed of the approach is impossible to overstate. This storm was moving forward at 60 miles per hour. That is a mile a minute. Morel turns back to the class. The math problem is still on the board. The unfinished equation. The chalk is still in his hand. He looks at those faces. 75 children. There is no basement. There is no siren. There is no time. The normalcy bias shatters in an instant. The ticking clock in the corner of the room, the one that marked the slow, lazy hours of a school day, is now counting down the final seconds of the world as they knew it. He opens his mouth to scream, to tell them to get down, to tell them to pray. But the wall of white is already here. Let's pause here, right at this moment, because this is the point of no return. Up until this second, everything was theoretical. The pressure drop, the green sky, the distant rumble. It was all information that could be processed. But nature has a way of switching from observation to participation in the blink of an eye. The physics we talked about earlier, the broomstick and the tree, that energy is currently screaming toward a wooden box filled with children. The roof of the Horrell Hill School is held down by gravity and nails. The wind approaching it is generating lift that is stronger than gravity, and force that is stronger than steel. We are about to enter the impact zone. We are about to witness what happens when an F4 tornado, a grinder, a shredder, collides with a 2-story building. We are going to hear the sound that L.B. Harmon heard. We are going to feel the wetness, and the cold, and the terror of a structure disintegrating around us. But the children inside, they don't know the statistics yet. They don't know that 71 of them will be the luckiest people in South Carolina history, and 4 of them will be gone before the chalk dust settles. The wall of white hits the glass. And the lesson is over. April 30th, 1924, noon. The timeline of a disaster is usually measured in hours or minutes, but when you enter the event horizon of a tornado, specifically an F4 wedge, time stops being a reliable measurement, time dissolves, it is replaced by sensation. James Howell Morel is standing at the window. The chalk is on the floor. The children are frozen. And then, the impact. We need to slow this down. We need to understand what happens when a structure, built by human hands, meets a force that is arguably the most violent concentration of energy on the surface of the planet. It begins with the air pressure. Before the wind even touches the siding of the school, the pressure inside the classroom and the pressure outside the classroom become catastrophically different. The tornado is a low-pressure vacuum, a hole in the atmosphere. As it envelops the building, the air inside the school, at normal atmospheric pressure, suddenly wants to get out. It wants to equalize. This is why buildings explode. It isn't just the wind pushing them over. It is the building itself trying to exhale. The first sound isn't the wood snapping, it's the glass. Imagine the windows. Old, single-pane glass, glazed into wooden sashes. As the pressure drops outside, the air inside pushes against that glass with tremendous force. Pop. The windows don't just break, they burst outward. Shards of glass, thousands of them, are instantly sucked into the vortex. They become shrapnel. They join the debris cloud, the wall of white that Morel saw coming, and then the wind arrives. Wind at 20 miles per hour is a breeze. Wind at 60 is a gale. Wind at 100 is a hurricane. The winds hitting the Horrell Hill School were estimated between 166 and 200 miles per hour. At that speed, air behaves like a fluid. It behaves like water. Imagine a tsunami, a tidal wave of water, hitting a wooden box. That is the physical reality of the force load. The schoolhouse didn't stand a chance, but it didn't collapse immediately. It fought back. For a second, maybe 2 seconds. The timber framing held. Survivors inside described a sensation that is almost impossible to comprehend. They said the building trembled, not shook, trembled. Think about the difference. Shaking is mechanical. A car shakes on a bumpy road. But trembling is biological. It's what a living thing does when it is terrified. It is a high-frequency vibration. The walls were vibrating so fast that the nails holding the boards together began to scream. This is a sound that haunts survivors of major tornadoes, the sound of nails screaming. As the wood flexes, the friction of the steel nail pulling against the grain of the wood creates a high-pitched, metallic shriek. It sounded like the school was crying out. Morel, the teacher, later said the impact lasted probably 30 seconds. 30 seconds? Close your eyes. Count to 30. It's a long time. It's an eternity. In that 30 seconds, the laws of physics inside that room were suspended. The normalcy bias we talked about in Act 1, it was gone, replaced by the survival instinct. But in a tornado, there is no fight or flight. You cannot fight the wind. You cannot outrun the wind. There is only freeze. The children, 75 of them, huddled under desks. They curled into balls. This is the fetal position. It is the most primal human response to trauma. We try to make ourselves small. We try to protect the vital organs. We try to return to the safety of the womb. But the womb was disintegrating. Let's go back to the sound. We mentioned the freight train. L.B. Harmon, the first grader, used those words, like a freight train. It is the most common cliché in tornado literature. If you watch the news after a storm in Oklahoma or Kansas, someone will always say, it sounded like a freight train. But in 1924, in rural South Carolina, this description was not a cliché. It was a literal interpretation of the noise. Why does a tornado sound like a train? It's a combination of frequencies. You have the deep, bass rumble of the vortex itself, the friction of the air rubbing against the ground. This is the roar. But then you have the debris, millions of objects, tree limbs, roof shingles, dirt, rocks, chickens, that broomstick we talked about. All of it is swirling at 200 miles per hour, colliding with each other. Crash, snap, bang. It creates a cacophony of mechanical noise, a grinding sound, like metal wheels on a metal track. For L.B. Harmon, huddled in the corner of his classroom, that sound was the only thing in the world. The roar was so loud it was deafening, literally. The decibel level inside an F4 tornado rivals a jet engine at takeoff. It is loud enough to rupture eardrums. Many survivors of tornadoes recall silence. They say, I didn't hear anything. But they didn't hear nothing because it was quiet. They heard nothing because their brain, in an act of mercy, shut down the auditory processing centers. It was too loud to process. So the brain simply hit the mute button. Harmon didn't have that luxury. He heard it all. He heard the roof of the school begin to lift. The roof is the most vulnerable part of any structure. The wind blowing over the peak of the roof acts like an airplane wing. It creates lift. Bernoulli's principle, faster air means lower pressure. Lower pressure creates lift. The entire roof structure of the Horrell Hill School, tons of lumber and shingles, wasn't blown off, it was sucked up. One moment, there was a ceiling above them, a barrier between the children and the sky. And then, in a split second, the sky was the ceiling. But it wasn't the sky. It was the wall of white. Imagine looking up, expecting to see wood and plaster, and instead seeing a churning, gray, violent blender of debris. The exposure was instant. The school was 2 stories tall. The second floor collapsed onto the first. This is the moment of greatest lethality. Pancaking. When the structural integrity of the walls failed, gravity took over. The heavy timber beams of the second floor came crashing down. For the children on the first floor, the world became a crushing weight. But the wind wasn't done. The wind grabbed the debris of the collapsed school, the walls, the desks, the floorboards, and turned them into projectiles. We have to understand the violence of the air itself. It wasn't just pushing, it was scouring. Survivors describe being sandblasted. The dirt and grit in the air was moving so fast that it stripped the bark off of trees. It scoured the paint off of cars. Imagine what that does to human skin. L.B. Harmon describes being wet as a rat. This is a specific tactile detail that tells us so much about the meteorology of the moment. The rain wrap of the tornado. Inside the funnel. It isn't dry, it is a washing machine. Water is being pulverized into a mist that is so fine and moving so fast that it penetrates clothing instantly. It soaks you to the bone in a fraction of a second. Harmon, a 6-year-old boy, is suddenly wet. He is cold. He is deafened by the roar. And he is watching his school, his sanctuary, disappear into the sky. There is a psychological phenomenon known as time dilation. When we are in mortal danger, the amygdala, the fear center of the brain, hijacks the system. It tells the memory centers to record everything. Usually our brain filters out the noise. It ignores the pattern of the wallpaper or the hum of the fridge. But when you are about to die, the brain records every single frame of video at high resolution. Because of this, memories of disaster feel like they happen in slow motion. For James Howell Morrell, watching the walls dissolve, time must have stretched into an eternity. He saw the desk sliding. He saw the blackboard, with his math problem still written on it, rip away from the wall and vanish into the white void. The logic of mathematics, erased by the chaos of nature. The wind was so strong it didn't just break the building, it atomized parts of it. Later, investigators would find books from the library, but they didn't look like books. The pages were stripped out, one by one, or the paper was fused together, matted into a pulp by the force of the water and the wind. They found chickens, plucked clean of their feathers, not by heat, but by wind stress. The follicles holding the feathers in the skin simply gave up against the friction of the air. This is the environment the children were in. The school, a large, sturdy building, was reduced to a pile of kindling in less time than it takes to tie your shoes. L.B. Harmon remembers the sensation of tumbling. He wasn't walking. He wasn't running. He was being rolled. The wind treats a human body just like it treats a piece of debris. A rag doll. Harmon was thrown. He landed in the wreckage. He looked around. The wall of white was passing over them. The center of the storm. We often hear about the eye of a hurricane. It's calm, sunny. The center of a tornado is different. It is a vertical tunnel of rotating air. If you are directly underneath it, you look up into a tube that goes up, and up, and up, seemingly forever. Some survivors of other tornadoes have described seeing lightning flashing inside the tube, a constant strobe light effect of electrical discharge, blue and purple arcs of electricity dancing around the inner walls of the funnel. Did the children of Horrell Hill see this? We don't know. Most of them had their eyes squeezed shut, but they felt the pressure change. The pressure inside the funnel is so low that it can cause nosebleeds. It can cause blood vessels in the eyes to burst. This explains the red eyes that rescuers sometimes see on survivors. Harmon, clinging to the ground, feeling the rain lash against his back. He was experiencing a barometric assault, and then, just as quickly as it started, the train began to pull away. This is the most jarring part of the survivor experience, the transition. In a movie, the music swells. The hero crawls out slowly. In a tornado, it is a hard cut. The wind is doing 160 miles per hour, and then, 10 seconds later, it is doing 20. The roar, the freight train, moves to the east. It fades. It doesn't disappear instantly. It rumbles away, like thunder rolling into the distance. But in its wake, It leaves a vacuum of sound, silence, absolute, heavy, ringing silence. No birds. The birds are gone, no insects. The insects have been blown away or killed. No cars, just nothing. The contrast is physically painful. Your ears are ringing. The adrenaline is still pumping through your veins, screaming at you to run, to fight, to hide. But the threat is gone, the monster has eaten, and it has moved on to the next course. L.B. Harmon opens his eyes. He is lying in the mud. He is wet as a rat. He looks up, and this is the image that stays with you. The sky is no longer green. The wall of white is gone. The sun comes out. April 30th. It was a humid day. The storm system was moving fast. Behind the squall line, the air was clear. So, moments after the school was leveled, the sun broke through the clouds, bright, hot, indifferent. Imagine the cruelty of that sunlight. It illuminated the wreckage with a perfect, high-definition clarity. It sparkled on the broken glass. It shone on the wet, splintered wood. Harmon stands up. He is shaking, not from the wind anymore, but from the shock. He looks around. Where the school stood, there is just a scar on the earth, a debris field. And then, the silence is broken, not by the wind, but by the children. At first, it's a whimper, a moan, then a name is called out. Mama, help. The sound of 71 survivors, and the silence of 4 who would not go home, began to fill the air. This is the walking wounded phase. The survivors of Horrell Hill were not just injured, they were in a state of cognitive dissonance. Their brains could not reconcile the reality of 5 minutes ago with the reality of now. 5 minutes ago, they were learning math. They were worried about a test. They were thinking about lunch. Now, they are standing in a ruin, covered in mud, bleeding from cuts they can't feel yet because the shock is masking the pain. One survivor, a young boy, was described as being white as a sheet. This isn't just a figure of speech. This is physiological shock. All the blood has drained from his face to prioritize his heart and lungs. He is a ghost standing in the sunshine. He walks toward the road. He doesn't know where he's going. He just knows he has to move. He sees the well, the old water well in the schoolyard, the curbing, the heavy stone or concrete ring that sits around the top of a well, is gone, blown out, ripped from the ground. Think about the force required to lift a concrete well curbing. It is heavy, it is low to the ground, it is aerodynamic. The wind didn't care, it took it anyway. This was the landscape they woke up to, a landscape where heavy stones fly like birds, and schoolhouses turn into splinters. As the dust settled, and the parents from the surrounding farms began to run, actually run toward the school, a realization began to form. 75 people were inside. The building is gone, by all laws of probability, by all the actuarial tables of insurance companies. The casualty rate should have been catastrophic. 50%, 80%. If you drop a building on 75 people, you expect mass fatalities, but only 4 died. Why? How? This is the central mystery of the Horrell Hill tornado. The miracle. Was it the way the walls fell? Did the desks provide a void space, little triangles of life that protected the children from the crushing weight of the timbers? Forensic engineers who study tornadoes talk about void spaces. When a wall falls against a solid object, like a sturdy oak desk, it creates a pocket, a bubble of air. In 1924, school desks were made of cast iron and solid wood. They were heavy. They were bolted to the floor. Those desks, those iron frames, likely saved dozens of lives. They took the weight of the roof. They held the timber off the bodies of the first graders. If the desks had been modern, lightweight plastic or particle board, the death toll would have been in the double digits. The old world construction, the heavy, over-engineered furniture of the 1920s, became the only shield they had against the sky. But for 4 families, the iron desks weren't enough. We must acknowledge them. We cannot tell this story as an adventure without acknowledging the cost. The search began immediately. Frantic fathers digging through the wet lumber with their bare hands. mothers screaming names into the indifference of the sunny afternoon. They found them, and they found the broomstick. We return to that image. The broomstick in the tree. It was found near the school, a piece of domestic life, a tool for cleaning floors, weaponized by the atmosphere. It stood there, protruding from the oak tree, like a marker, a monument. It was nature saying, "Look what I can do. Look how I can change the rules." The parents pulled their children from the wreckage. They loaded them into wagons, into Model T Fords, and raced toward Columbia, toward the hospital. The road was littered with trees. Power lines were down. It was an obstacle course of destruction. But the storm wasn't done. The monster had left Horrell Hill. But it hadn't left South Carolina. It was still on the ground. It was churning east, toward the watery swamp, toward Darlington. It had only just begun its long, scarring walk across the state. The Horrell Hill School was just a waypoint, a brief stop on a 135-mile journey of violence. And as the survivors of Horrell Hill sat in the mud, trying to understand why they were alive, the people in the next county were looking up at the sky, and they were noticing that the sun was starting to look a little green. We need to pause and contextualize the scale of this event before we move to the aftermath. We threw out the number earlier, 135 miles. In the world of tornadoes, path length is a key indicator of power. Most tornadoes are short-lived. They touch down, they skip, they lift, they are chaotic. Spasms of the atmosphere. A typical tornado might stay on the ground for 5 miles, maybe 10. A long-track tornado is a different beast. To stay on the ground for over 100 miles requires a storm system of immense size and stability. It requires a perfect balance of inflow and outflow. The engine has to be perfectly tuned. The Horrell Hill tornado, retroactively rated F4, was a marathon runner. It crossed rivers, it crossed hills, it crossed swamps. It didn't care about the terrain. Usually, rough terrain disrupts the airflow of a tornado. Hills can break the suction. This storm was so powerful, so organized, that the topography of South Carolina meant nothing to it. It traveled the distance from Columbia, almost to the Atlantic Ocean. It ground a path the width of 6 football fields. Imagine a bulldozer, 600 yards wide, driving from London to Birmingham, or from New York to Philadelphia, and not lifting the blade once. That is what happened on April 30th, 1924. And as we prepare to look at the investigation, the why and the how, we have to ask ourselves, if this happened today, with our suburbs, our glass office buildings, our highways clogged with traffic, would the death toll still be 53? Or would it be in the hundreds? The Horrell Hill tornado hit a rural, sparsely populated world. It hit a world of wood and iron. If it hit the world of glass and plastic we live in today, the story might not be about a miracle. It might be about an erasure. The sun is shining on Horrell Hill. The children are weeping. The teachers are bleeding. But the sky is blue, and the silence is deafening. The sun is out. The wind is gone. But there is a smell. Survivors of tornadoes often talk about the sound. But the smell, that is what triggers the nightmares decades later. It is the smell of pine resin. Imagine thousands of pine trees, snapped in half instantly. The sap, the blood of the tree, is aerosolized. It coats everything. It mixes with the smell of wet earth, the smell of ozone, the smell of natural gas from ruptured lines, and, underneath it all, the copper, metallic tang of human blood. At the Horrell Hill School, the silence didn't last long. It was replaced by the chaotic, disorganized noise of triage. In 1924, there were no helicopters, no FEMA, no cell phones to call 911. The first responders were farmers, men in denim overalls running across fields, their boots sinking into the mud, women tearing their petticoats into strips to make tourniquets. They arrived at the school to find a scene that defied logic. The building was not just flattened, it was scattered. Debris from the school would later be found 30 miles away. Think about that distance. 30 miles, a piece of the blackboard, a textbook, carried across the county line by the upper-level winds. But right now, the focus is on the immediate radius, the impact zone. We need to talk about the bodies. Of the 53 people killed by this tornado across the state, roughly half were children. At the school, the miracle we spoke of, the desk saving the lives of the students, was not a guarantee. It was a game of inches. If you were under a desk, you lived. If you were in the hallway, if you were near the door, the outcome was different. The injuries were medieval. Tornado wounds are not like car crash injuries. They are blunt force combined with penetrating trauma. Deep lacerations from flying glass. Puncture wounds from splinters of wood moving at 200 miles per hour. Degloving injuries where the skin is stripped from the muscle by the sheer friction of the wind. The parents, frantic, terrified, began to pull the timbers off the pile. This is where the story becomes difficult, because we have to talk about who these people were. In 1924, South Carolina was a place of deep, systemic segregation. It was the height of the Jim Crow era. The Horrell Hill School was a consolidated school for white children. The structure was relatively sound. It was built with tax dollars. It had a frame. It had a foundation. But the tornado didn't just hit the school. It hit the surrounding countryside. It hit the tenant farms. It hit the sharecroppers. If we look at the demographics of the death toll across the entire 135-mile path, we see a stark statistical reality. The African American population in rural South Carolina lived primarily in chattel houses. These were shacks, often unpainted, raised on cinder blocks or stones to keep them off the wet ground. No foundations, no anchors. When an F4 tornado hits a well-built school, it collapses it. When an F4 tornado hits a sharecropper's cabin, it doesn't collapse it. It erases it. The structure disintegrates. Statistics from the 1920s are notoriously incomplete regarding African American casualties. Coroners often didn't record the names of black victims with the same diligence as white victims. They were sometimes listed simply as Negro male or unknown. However, modern analysis of the 1924 outbreak suggests that the fatality rate for African Americans was disproportionately high. Why? It wasn't biology. It was physics, applied to economics. If you are poor, your walls are thin. If you are poor, you have no storm cellar. If you are poor, you have nowhere to go when the sky turns green. The monster we have been tracking didn't care about the color of the skin, but the infrastructure did. This brings us to a grim realization. The miracle at Horrell Hill was partly a miracle of construction. The school had bones. The shacks did not. As the afternoon wore on, the wagons began to fill up. Model T Fords, their suspensions groaning under the weight of the wounded, began the slow, torturous drive to Columbia. The roads were blocked by fallen oaks. Men had to get out, cut the trees with axes, move the logs, drive 100 yards, and do it again. It took hours to get to the hospital, and all the while, the sky was clearing, the humidity dropped, the evening became cool and pleasant. Nature, having thrown its tantrum, was settling down for a quiet night. Now, we must pivot. We must leave the mud of 1924 and step into the laboratory of the present day. We have called this storm an F4. But in 1924, the Fujita scale did not exist. Tornadoes were not rated. They were simply bad or very bad. Dr. Zixtain, Tetsuya Theodore Fujita, the man who would eventually categorize the wind, wouldn't introduce his scale until 1971. So, how do we know? How can we look back across a century of time and assign a number to a ghost? This is the science of retroactive analysis. Meteorologists and historians act as detectives. They don't have radar data. They don't have satellite imagery. They only have the damage indicators. The Fujita scale is not based on measured wind speed. It is based on damage. If a tree is snapped, that's one speed. If a roof is torn off, that's another. If a house is swept clean from the foundation, that is the maximum. Let's look at the evidence from Horrell Hill. Exhibit A, the schoolhouse. The walls collapsed, but the debris remained largely on the foundation or near it. Verdict, F3 damage. Winds approx 140 bph. Exhibit B, the well curbing. We mentioned the heavy concrete ring of the well, ripped from the ground. To lift a heavy, low-profile object requires intense vertical suction. Verdict: high-end F3 or low-end F4. Exhibit C, the tree bark. Survivors and witnesses reported trees stripped of their bark. This is a specific signature. It requires wind speeds in excess of 170 km/h to scour bark from a hardwood tree. Verdict: F4. Exhibit D, the path length. 135 miles. This is the smoking gun. A typical tornado is a sprint. It burns a lot of energy very quickly, and then it dies. To maintain a violent tornado for 135 miles requires a supercell thunderstorm of almost perfect efficiency. Think of a supercell as a heat engine. It sucks in warm, moist air. It exhausts cold, dry air. If the exhaust gets sucked back into the intake, the engine chokes, the storm dies. The storm of April 30th, 1924, had a perfect exhaust system. The upper-level winds, the jet stream, were venting the cold air away from the storm, allowing it to inhale fresh fuel for hours. It was a self-sustaining monster. We must also consider the width, 600 to 1,000 yards wide. When a tornado gets this wide, it often develops multiple vortices. Imagine the main funnel, the big wedge. Now, imagine smaller, more intense tornadoes spinning inside the big one. These are called suction vortices. They are like the teeth of the buzzsaw. The main funnel might be spinning at 150 mph, but the suction vortex inside it adds its own speed to the rotation. 150 plus 50 equals 200. This explains the randomness of the damage. Why was the broomstick left in the tree, but the car next to it was destroyed? Because the car was hit by a suction vortex. The tree was missed by inches. It is a game of Russian roulette played by the atmosphere. This forensic analysis tells us something chilling. The Horrell Hill tornado was not a freak accident. It was a predictable result of atmospheric thermodynamics. When the conditions are right, the sky will always do this. It isn't malice, it's math. We are now nearing the end of our timeline. The debris has been cleared. The school was eventually rebuilt. The scars on the land have healed. If you go to Horrell Hill, South Carolina, today, you won't see the path. The pine trees have grown back. The fields are green. Nature is resilient. It covers its tracks. But the human scar remains. We need to talk about the psychological aftermath. In 1924, there was no diagnosis for PTSD. There was no counseling. The children of Horrell Hill were told to be thankful and move on. But you don't move on from the sound of the freight train. L.B. Harmon, the boy who was wet as a rat, lived a long life. But like many survivors, he watched the sky. Every spring, every time the humidity spiked, every time the clouds turned that bruising shade of purple-gray, he remembered. This is the legacy of the storm. It isn't just the wood and the glass. It is the permanent alteration of the survivor's relationship with nature. Before the storm, the sky is just scenery. After the storm, the sky is a threat. And this brings us to the present day. We live in an era of Doppler radar. We have tornado warnings on our phones. We have safe rooms and building codes. We like to think we are safe. We like to think we have tamed the monster. But let's look at the data. The population of the American South has exploded since 1924. Where there were once cotton fields, there are now subdivisions. Where there were dirt roads, there are interstates. If the April 30th, 1924 tornado happened today, on the exact same path, it would not hit a few scattered farms. It would hit the suburbs of Columbia, it would hit strip malls, it would hit hospitals. The target is bigger now. We are building more and more targets in the path of the gun. Meteorologists call this the expanding bullseye effect. The storms aren't necessarily getting stronger, but we are getting denser. The Horrell Hill tornado killed 53 people in a world of wood. What would it do in a world of glass? As we close the file on April 30th, 1924, we are left with a final image, the broomstick. It remained in the tree for years, a local curiosity. People would drive by to see it, the straw that pierced the oak. Why do we find that image so compelling? Why does it stick in our minds more than the destroyed school? Because it represents the impossible. It represents the moment when the rules of our reality were suspended. We live our lives governed by gravity, by friction, by the solidity of objects. We trust that a wall is solid, we trust that a tree is hard, we trust that a broom is soft. The tornado reveals a terrifying truth. We are only solid because the air lets us be solid. We are only safe because the atmosphere allows it. For 30 seconds in 1924, the atmosphere changed its mind, and the soft became hard, and the solid became vapor. We tell these stories not to scare you. Well, maybe to scare you a little bit. Fear is a survival mechanism. Fear makes you check the weather. Fear makes you build a kit. But we also tell these stories to honor the resilience of the human spirit, to honor the teachers who stood by the windows, to honor the fathers who dug through the mud, to honor the children who crawled out of the darkness and walked back into the light. The wind blows, the buildings fall, but we stand up. We rebuild. We plant new trees, and we keep watching the western horizon. For the True Disaster Channel, I'm Stay Safe and keep your eyes on the sky.